Hello everyone, this is Venkatashat from Gokaraju Rangaraju Institute of Engineering and Technology, CSC department, and our team members are Sahit, Shivakrishna, Gunateja, and Ravichandra. And our project title is Smart Attendance Management System, and we have completed our project successfully under the guidance of D. Vishasri ma'am, Assistant Professor in Department of CSC. Nowadays, every organization using manual attendance technique for attendance during class hours is often time consuming, prone to errors, and lacks efficiency. This will result difficulty accurately tracking and managing attendance, resulting in challenges such as inaccurate attendance records, long waiting times for participants, and the potential for fraudulent practices such as proxy attendance. To address these issues, we propose a smart attendance management system to automate the process and enhance efficiency, accuracy, and convenience. This system leverages facial recognition technology to streamline attendance tracking and management. By using face detection and recognition techniques, it will automatically detect the students present in the classroom and mark the attendance by recognizing the student. Firstly, the camera will capture the image of the student during the class hours, and it will verify with the database using convolutional neural networks algorithm. By utilizing this algorithm, the system offers a more efficient and accurate way to identify and authenticate participants based on their facial features. And this and it will store. Then the system generates comprehensive reports and analytics based on the captured attendance data. So the so our main goal, our project main goal is to overcome the and our and our project main goal is to overcome the challenges associated with the traditional manual methods. This will advance the technology, improves efficiency, accuracy, and security while providing a seamless experience for participants and valuable insights for organizations. In the system we are using CNN algorithm. It is made up of multiple layers, including convolutional layers, pooling layers, and fully connected layers. In convolutional layers, the filters are applied to the input image to extract features such as edges, textures, and shapes. Then the output of the convolutional layers is passed through pooling layers, which use it to downsample the feature maps and reduces the spatial dimensions. Then the output of the pooling layers is passed through one or more fully connected layers, which are used to make prediction or classify the image. Then by using this algorithm, the system will can able to recognize the face of a student easily. But sometimes CNN algorithm shows less accuracy and it can't able to detect the face of a student. To overcome this situation, we are using MobileNet V2 model, which does the same convolution as done by the CNN to filter the images, but in a different way. In this model, we are using depth convolution and point convolutional, which is different from normal convolution as done by the normal CNN. And by using these convolution layers, it will increase the efficiency of CNN to predict images and can able to compete in mobile systems as well. This is the code for dataset creation of project. In this code, we are importing some modules. Then in this module, so CV2 is for image processing and O is for handling file system operations. And then we will set up a save path variable to save the path of the dataset created. And it will first we will take input of the student roll number and create a directory for the person. In this uh, in this method, os.make the DRS function is used to create directory recursively if needed. Then load the face cascade classifier. In this face cascade classifier, R cluster classifier for detecting faces is loaded using CV2 dot cascade classifier. Then and this cascade front place default XML is it contains pre-trained models for detecting the faces, and we will open the webcam using cvt.video capture and start capturing images, and then capture and pre-process frames from webcam inside while loop. Inside while loop, the code read frames from webcam using cap.read function, and then capture frame is converted to grayscale using cv2.cvt color, and face cascade detection is used to detect the faces in a grayscale frame. For each detected face, a rectangle drawn on the original face using cv2 color cv2.rectangle method, and the count variable is used to increment of each image captured, and the loop continues until the 500. Then we will use cap.release to free up the system from resources, destroy all windows, and display the enter successfully message. Now we will look into the execution of the code. It shows the enter the student's roll number. Now I entered the student roll number. Like this, it will capture the image of students and print entered successfully. Then the stored images will be entered into the new data set with the respect to roll number. Like this, it will store the images of the each and every student. Go for pre-processing in our project. In this code, we are importing necessary libraries, and in this we will define the path and the image size. Then we'll define a function of the pre-processing image. In this, we'll create an image data generator for train data, and we'll load the train data using image data generator. In this, we will load the validation data using image data generator. Then we will create a model using the mobile net with pre-trained weights in to this variable. After the creation of the base model, we will freeze the layers of the base model and add the additional layers on the top of the base model, and create the final model by specifying the inputs and outputs. Then we will compile the model. We will compile the model with an optimization and loss function and metrics, and train the model using the train data and validate on it. Then we will save the trained trained model in a file, and I'll show the execution of the pre-processing. First, we'll run the model. Then we'll start pre-processing the each and every images in the for the given data set. It will check each and every approach up to 30 approaches. It will validate the data set by checking the approaches up to 30. Now the execution of the pre-processing is done. This is the code for testing in our project. It will import some necessary libraries. First, it will load the model from the pre-processing from the saved pre-processed. Then it will classify it, and it will take the path of the dataset which is saved. Then it will read the Excel sheet. Then it will pre-process the captured frames and update attendance in this process. Then it will checks if the count is then it calculates the maximum count of attendance and iterates through each label and its count. Then finally it will check if the count is greater than or equals to 60%. It will mark it as present, else it will mark it as absent. And finally the update it will save the updated attendance sheet to an Excel file. Then print the attendance updated for and print attendance sheet. Now let me show you the execution of this code. First we'll run the module. Then it will scan the face of a student and mark the attendance of to the particular student in an Excel sheet. Now let me show you that Excel sheet. Now in this Excel sheet you can observe the particular person got attendance. The particular person got present in attendance. Our project first initializes the camera and collect the data set of each student up to 500 and pre-process and train the model. Then it will test the model. Then it will shows the output of a particular person or attendance in a particular date.